I hope most of you join the class. Okay. So shall we start? Okay. Let me share the screen. But so can you see the screen? Okay. So today we'll be seeing statistical thinking or statistics for data science. Okay. So statistics is something very much important. And then again, in the statistics, the same thing comes, the mean, median, mode. Today's class will be more of a practical exam. I mean, theoretical examples and verbal teaching than uh, practical. Okay, because in statistics, if you understand the practical is quite easy, but if you don't understand how to think statistically, then it's quite difficult. So. Uh, the notes of yesterday's class I have not uploaded because I haven't corrected the orders or I haven't done the changes what are required to be done. Okay, so if I don't send it by next Sunday, I want someone, any one of you to, any one of you, please remind me. So today's there is some errors in the code which I was not able to fix in time. So I continued the class. Okay, so let's start with today's class. So the first part is nothing but we are just loading the data. Okay, so why statistics after ADA? Like yesterday we finished ADA. Today, why do we start with the statistics? Because what ADA does, it shows what appears to be happening, right? Happening what appears to be happening in the data set. So statistics helps us decide whether it is meaningful or not. That's why we are doing statistics after AD. Next, so EDA was nothing but your visualization intuition, right? So what you can do in the data set. Statistical is nothing but we are validating the whole uh, visualization with the mathematics. For example, in the industry, decisions are never, if you see, decisions are never made on the basis of visual data. Visual data can be anything, right? So it can be sometimes wrong. So most of the decision in the industry are made with the help of statistical thinking or statistical data. So coming to what is statistics. So I have already explained why statistics comes after ADA. Okay. See, here it's given in detail, like why exploratory, like why it's critical, why statistics is a critical role after visualization, and one here are the reasons I have defined here. This is quantify relationships, then test hypothesis and all. I want you to see, as I told you, I want you guys to develop the habit of reading. I hope you read whatever the assignment I gave yesterday. because those are the important topics of data science as well as data analysis. Okay, so these are the right now these are the basics we are doing, and whatever I tell you to read, please go through it. Okay, next, uh, we'll see what is statistics. Okay, so statistics in textbook definition, if I want, if I should say that, then that will be, statistic is a branch of mathematics concerned with collecting, analyzing, and interpreting and presenting data to support decisions. Okay, and making and we have to and supporting those decisions which um, are made under uncertainty. So why uncertainty matters? Data is only a data is only a sample, so not an entire population, right? So that's why uncertainty matters. So sometimes samples can be missed, and there comes the statistics that helps to control the risk of wrong decisions. There are different types of, so see, this is how see any statistics, this is how it looks. So when you take the same yesterday's data set of performance of students, so here you can see the statistical scores, the mean, median, standard deviation, skewness, and uh, this I'll teach you later when it comes. Okay, so this is how this statistics looks like. So there are different types of statistics or correlation, core classification what you can do. So the first type is descriptive statistics. So descriptive statistics is nothing but what I showed you right now, which describes what the data looks like. Example: mean, median, standard deviation, or percentile. So that's the first kind, which is descriptive statistics. Next, after descriptive statistics, we there is something called inferential. Sorry, quantitative interpretation, which is descriptive statistics, as I told, mean, median, standard deviation, skewness. Okay. Next, uh, why it's why purely visualization analysis can be misleading. It's why I have given here. Uh, See, when you look at a visualization, that doesn't mean it's everything what you see in the dashboard is true, right? So sometimes if you don't clean the data and you directly go to dashboard and do the analysis of of your data set, the whatever the visualization you see will be according to that data without cleaning. So it can be misleading most of the times. Okay. So next comes inferential statistics. So here I have, I guess I mentioned one. So there is another called inferential statistics. What it is? So sample data to make, we use sample data to make a conclusion about a population. For example, we have around thousands of rows, and we take a sample data of around just 20 rows, and we conclude it is same for the entire population. But most of the time it might not be true. In some cases it might be true, but in most of the cases it might not be true. So that's what inferential statistics is. So the examples are like hypothesis testing. For example, yeah, the hypothesis of ice cream and the shark attacks. Next comes the like confidence intervals or statistical significance. So today we'll be focusing on these things. Okay. From today onwards, I guess yeah, 2 or 3 classes will be focusing on these statistical data and how to do it, like hypothesis testing, confidence interval. Those will be looking at. See, I have also given industry examples because I know no matter how much I tell you to look into the industrial examples, you won't look at it. So there is a drug trial test and A/B testing, and there is market trend analysis, which is an industry examples. Okay, so I have provided it here. So at least now go through it. I'll say one of them. Okay, which is drug trials. So in medical research, like visualization improvements in patients' outcome after a new drug are not enough, right? So for example, what this basically the drug trial says. So uh, in India, it doesn't happen most of the time, like most of the times, because we import medicines and we rarely, whatever the medicines we make, we already have tested for it. But in Western countries, what they do is if they have any new medicines, they'll test it on people, volunteers who would be willing to take those medicines for a cost. So those are drug trials. Okay. Even sometimes the drug trials are made without our knowledge. Like they'll give a new medicine to a patient and they'll test it on us. So this happens all over the medical industry. But so what drug trial data set does is we have to analyze those uh, test trials where uh, which has cured the patient completely and which has not cured the patients completely. So like rigorous statistical trial are paramount to ensure observe effective effects are statistically significant and not due to chance or uh, placebo or like there is something called placebo effect. Okay, or confounding factors. So if some medicine worked for you, that doesn't have to work for the another guy. So we have to look at the majority, like for how many of the people it works and why it works. And so that's what statistical analysis mainly about. Okay. Now let's. Okay, you understood about the types, right? So let's come to population and sample. So when I say population, what comes to your mind? The when you take a chunk of people in just one state, it's not the entire population of the country, right? So similarly, when you take a chunk of data like 10 to if there is 10,000 rows, if you take just 20, that's a sample. Okay. So the definition would be a subset selected from the population. So population is nothing but the entire group of the interest. Entire group of interest means whatever the data set we are looking into. For example, let's if I take the current data set, which is a students' performance data set, that is yeah. In that we can also take the population as if we segregated it in the country or the country or state, we can take the all students in one state as a population, and sample will be that students in this data sets. So here I've given the detailed explanation about population and sample. So population refers to the entire group of individual or item that we are interested in studying. For instance, if we are studying students' performance, the population might be all students in particular country, as I said, or all students enrolled in specific types of course. Okay, sample inherently differ from population due to random variation. So even a perfectly chosen representative sample will not perfectly mirror the population. Okay, so the whatever, so what that basically means is, so when you take a chunk of data, that doesn't have to represent the whole data, because at some point there will be changes, or at some point there will be extreme cases as well, or whatever the sample you have taken, that might not represent the actual scenario in the data set. So that's what the sample and populations are. So once you understand these, then your statistical thinking actually the process begins. Okay. So I told you about central tendency, right? Central tendency, like yesterday we were talking about. I forgot the term yesterday's. What we anyone remember what did I tell yesterday? Central. I said something. See, I have lot of other works, but you have just this internship and the college work right now. So you have to remember this. Anyone in the chat? Nope. I guess today everyone is sleeping. So we'll start with the central tendency, like measure of central tendency. Okay. So measure of central tendency is nothing but it describes the center or typical value of a data set. Uh, so for example, the like what are the things that comes in central tendency is nothing but again the mean, uh, then comes the median, then comes a mode. So here in the mean score we can take the math score. There can be an extreme like sensitive extreme values, or which is not represented in the data set. So central tendency is nothing but it's like measure of central tendency is nothing but a center or a typical value. Okay. So this is for the first part. I guess there is one more. Okay, here I have given clearly analysis of population versus a sample statistics. Okay, so in the original data frame there are so much of in my data set there are so much of rows. I took only this as a sample. Here you can see statistical for total scores. Okay, mean population this, and the standard deviation this, and you can see here sample is this, and sample standard deviation is this. Here there is no much of a difference. But if you see the weekly study hours, like mean is 15.03, and here the sample mean is 15.07. So you might say that 0.4% is not much of a difference, right? So but it is much of a difference when you statistically think about when we are talking about revenue or something else in business point of view. So here it is descriptive versus inferential data set, which I just completed. So this is about the descriptive statistics, and inferential. So yeah, inferential, like I already told, inferential statistic involves using data from sample to make generalization of generalization or draw conclusion about a large population. So you can also say sample data set, whatever we do the sampling, right? Uh, those are also inferential statistical values. So okay, Yeah, I have given no detailed notes. Okay, just I don't want to make you sleep when I do the sessions. That's why I don't explain much. So measure of central tendency. This is what. See, you don't have to remember the formula, but you should know the formula how it works. Okay. So mean, most of you know, it's just mean. Next median, similarly mode. See here the central tendency or the typical value are in the total score are 84, 87, and 100. So mean is 84. So most of the people typically score around 84, and their total score would be around 84, and even median same. But mode is nothing but uh, how do we calculate mode here? Where is it? For mode there is like no specific formula. It's simply the most like frequent values, like which are the most frequent value occurs in the data set. Okay, so I have interpreted as well here whatever the things I've done in the code. Okay, so that you won't have to look what the code means. So now coming to measure of dispersion. So what is measure of dispersion? It basically means what it does is it describes how spread or yeah, it describes how spread out the data values are around the center. For example, like I told yesterday, uh, there will be a normal distribution, right? So in the center there will be some amount of values. So in here dispersion means how uh, how spread out the values are around the center. So what are the things or in those dispersion there comes a range and variance, then comes a standard deviation. So let's talk about range. Okay, the range is simplest measure of dispersion. It's a difference between highest and lowest value in the data set. So range, how do you calculate range? So maximum value minus minimum values. I guess you might be you might have seen those in the social Amazons. There will always be a price range, right? So that's how they decide. There will be hundreds of products in the market what you're searching for, and your price range would be something different. So uh, whatever, however they depict the data in the social uh, e-commerce sites, that they do it by using a statistical method called a measure of dispersion, and they check what is the minimum value they have for the a particular product, and they check what is the maximum value they have for the product, and then they put a formula of range to it. So some products doesn't exceed some amounts, okay, and it doesn't have a lower than some amount. So at that time, even you can purchase easily. That's how statistics works in e-commerce and all. The range works. Then comes variance. So variance is a measure. Variance measures the average of square difference from the mean. So what it basically means is uh, the two data set can have the same mean but a very different variability, which means like a higher variance indicates that data points are spread out over the wider range of values. Okay, while the lower variance indicates that data points are clustered. I have a graph. I had a graph for this. I'll show it in a while. Okay, somewhere down. Okay, I'll tell you what the variance is there. And variance and standard deviation. So range, there is range, there is variance, and then there is standard deviation. Okay, in statistics. So these are the things you should know about. Statistics is quite a very small topic if you are verbally talking about it, but if you are doing it, it's quite big. But when you are discussing the statistics of the data set, then it becomes a big topic because you have a lot of things to consider. Okay. Where was I last? Probability attributed. So interpretation. I have given the interpretation here. So range, how the range looks, how the variance looks, how standard deviation looks for total score as well as weekly self-study hours. Okay. Okay. Let's come to probability. So I guess most of you have learned what is probability. So probability is a measure. Probability measures the likelihood of an event occurring. Okay. Uh, I guess that's what in layman terms probability is. But here is a detailed definition of it. So for example, there could be the score, like probability a student scores above 70, and probability of passing in an exam. So there are different things you can do in probability. So the key concepts would be the event occurring and the outcome, then the sample space. So an outcome or a set of outcomes from a random uh, experiment. For example, a student getting a grade A or a student studying more than 10 hours a week. So the probability if the student is studying more than 10 hours a week, then he'll get a grade A. And the outcome like a single possible result of a random experiment. So you're conducting any experiment, you will always look about the probability and the possibilities, right? So that's what. And probability always ranges from 0 to 1. So 0 indicates the impossible event, and 1 indicates a certain event which ranges from 1 to 100. Chances of some event occurring is 1 to 100. So like in data science, most of the time we will be expecting this to estimate these probabilities. Okay, like will a customer buy a product or not, depending on the price or depending on the features. Those are all the probabilities what you have like in the real world example. Next, here's the probability of total score greater than 90. Uh, so there is a formula for formula is nothing but, I mean, not formula. Probability of total score greater than 90. Oh, okay, sorry, I got distracted by the uh, things I have written. Okay, so the basic concept of probability, you got it right. Like so here I have written for like probability of grade being A, then probability of weekly self study hours. So here I have given the examples, I mean explanation. So we'll interpret the first one, the greater than 90. So what this basically means is like there is a 45% chance that a randomly selected student from the data set will have a total score greater than 90. So this is the like this is relatively high probability, like comparatively most of the time you won't be having that 45% chance and all. It depends on the data set and on the market analysis what you have done previously. Like why this probability is significant for in this scenario, like for educators this suggests a successful curriculum or a student body with a strong academic inclination. So it might also prompt further investigation into what factors contribute to such high performance, or if the assessment is like adequately challenging for students or not. So similarly I have given for the probability of student grade A being 0.55, and I also given for the another one. So just go through it, okay. So okay, even the boolean conditions like true or false comes under probability of itself, okay. So like what actually statistics is, so it does important thing in statistics is you need to know, which is it doesn't remove uncertainty, it helps you to manage and measure the uncertainty, okay. So you cannot remove uncertainties with the help of statistics. It will help you to understand and manage and measure, like in the what amount those uncertainties are present in the data set. So this will be for the first part of today's session. So next we'll go to statistics, hypothesis testing, or what we call it as statistical decision making. So what is hypothesis? So in layman terms, hypothesis is a testable statement or assumption about a population parameters, or about population parameter based on a sample data. So you can see, right, you can go through here with the actual definition if you want. So hypotheses are not guessing. So they don't claim they can be like tested using data, okay. So what are the good hypotheses contain? So let's see that. So good hypotheses are testable. It can be like investigated through observation, experimentation, or data analysis. So anything which can be experimented on or observed or can do the data analysis on, so, which is basically a testable ones, are a good hypothesis, are a sign of good hypothesis, one of the signs. So next is uh, falsifiable, like we can prove something, some evidence is wrong or something is right with the help of hypothesis. So basically you've been learning hypothesis since the 8th grade, I guess, in mathematics as well as science or physics. But here today you'll be like knowing why like what hypothesis actually is. And the hypothesis should be specific, so like it clearly defines a variable and periodic relations. Then it often like grounded in prior knowledge. We should have some knowledge about the a data set or something what we are putting our hypothesis on test. Okay, so there are like what is the crucial role of hypothesis. So what hypothesis helps us doing is guides the research. Then it structuring experiment and analysis. So it helps us structure the analysis and experiments, and it also helps us with focusing on our particular inquiry or whatever we are looking for, and it provides a framework for analysis. So most of the time we would be needing a framework for analysis what we will be doing, so that will be provided by hypothesis. So before you start working on any data, you should be able to hypothesize what that data is doing and what it is proving, and what are the things can be done in the prior knowledge of the data you should be having. Okay, and this also helps in enabling data driven decisions. So here's the explanation for it. So see, when we talk about hypothesis, there is something what we claim, and there is something which we have evidence for. So claim is an assertion or a statement that something is true. So we are saying something is true, and we are claiming that it's true without having an evidence. Sometimes, or sometimes we have evidence. So it can be an opinion or a belief or a processed fact. So a claim itself does not necessarily need to be tested or supported by data. Okay. So for example, most of the time when BTU implements something, they'll say our teaching new method improves students' performance, but it doesn't happen most of the time, right? So that's a claim. So it doesn't have to be proved. What is evidence? So evidence consists of facts, data, observation, or information that indicates whether a belief or a proportion is true or valid. So here I've given how hypothesis bridges claims and evidences. Okay. So I guess most of you have heard about null hypothesis. Have you heard about null hypothesis before this? Yes. So null hypothesis in basically nothing but it states that there is no effect or no difference or no relationship. Okay. So null hypothesis basically states that there is a no effect on data or no difference or no relationship between the data. The relationship or effect between the data is null. So the proper definition would be the null hypothesis is a statement of no effect, no difference, or no relationship. It represents the status quo of the default assumptions. So that we are trying to test. It typically states that any observed difference, effects, or relationship in a sample data is due to random chances. Today I'll be like mostly reading the things what I've prepared, because yeah, I just got a headache and I can't explain you most of the things, but these are the important things I'll explain in a layman term. And again, I'll be giving you these notes, but I want you to since this is just the first week, I don't want to start with the direct working on data sets, but I want to start with the data sets from second week. So what I want you guys to do is find out some of the data sets you are interested in or you want to work on. So we'll every day we'll work on any one data set which is provided by you. Okay, so at that time we'll understand directly how and what we have to do in a data set, and what the data analysis will be, and what data science people will be doing in the industry. Okay, you can do it parallelly along with me, but you can also just note it down and do it later. It's up to you how you do it. But from next week onwards, we'll start with the practical classes. So this week I want to completely tell you how and what are the basics, fundamentals of the data science and data analysis. So you will be feeling. I guess this week is almost over. Saturday, if possible, if it's early, I'll take 2 classes. If no, I won't take classes. Next week, for 2 or 3 classes, I'll take it verbally with these notes. Then we can start with the practicals, because there are a lot of things I have to tell it to you, the fundamentals, which I can't tell it once I start with the practicals directly. Okay, so bear with this 4 or 5 classes, the next 4 or 5 classes. Okay, it will be a little bit boring and it will be informative if you listen and if you are interested. So okay, we you saw what is null hypothesis is, right? So next we'll come to alternative hypothesis. So the alternative hypothesis is a statement that contradicts the null hypothesis, which means it represents the claim or theory that a researcher is trying to find evidence for. So what is the role in hypothesis testing? What is the role of alternative hypothesis in hypothesis testing? For example, if we reject the null hypothesis, it implies that we have sufficient evidence to support the alternative hypothesis. Okay, the alternative hypothesis that we would conclude if our experiment shows a significant effect. Let me give you 2 examples. Like in the null hypothesis, like it represents the default assumptions. Like what are the default assumptions will be there, right? By looking at the data, that we say it as null hypothesis. And if that assumptions are proved wrong in at some point with the with test preparations or anything, for example the math scores, then we call it as a alternative hypothesis, because it proved our first default hypothesis wrong, or it proved we have some evidence for the null hypothesis to be false. So this is about the hypothesis. I have given the example 2 here. Okay, I just don't want to. I just gave you the simple example verbally right now. Then, if you want some complex examples, it's here. So these are the fundamental logic behind it. We saw that. So next comes the decision-making mindset in hypothesis test. This you have to read, but when we do it only, you'll understand what are the like decision-making mindset you need to have while having a hypothesis test. Okay. So if I tell it right now, also it's quite it will go over your head. If you want, I can tell, but just give me a thumbs up if you want me to continue, or just heart if you want if you want me to read this and explain this. I'm getting nothing. I'll continue. Okay, thumbs up. Nice. So there are different types of hypothesis. Okay, so first one is T test, then comes a Z test or Z test, then comes chi square test. Okay, then comes a nova test, So these every test depends on what are the things what we want. So t-test most of the time it comprises of like comparing means. If we have two data columns, then we compare mean with the help of t-test. Then z-test is z-test or z-test is for large samples. If you have large amount of samples and we want to know the variance, then z-test is used. So here it's given in detail about the testing. About t-test I have given here, okay. About z-test have not given. I want you guys to look at it and just study about that. And there is something called chi-square test as well. Look at it, okay. So mm, uh, before running any test, there are some assumptions that must be checked. So the first assumption would be is data numerical? Then because most of the times you can't perform the analysis or statistical analysis with the numerical with the categorical data. Okay, so data is approximately normal in this assumption t-test. So we can see data is approximately normally distributed. So that we have to check, is it normally distributed or not. Then what we have to check is samples are independent. So this how to prepare practically for t-test as well. I have given it here, but if I do it right now, you won't understand. We'll do it along with the practicals. So let's set a deadline for these verbal or theoretical classes. Okay. So by 11th, which will be next Wednesday, we'll complete with the theoretical classes, because we must and we have to do the theoretical classes because you won't understand. There are a lot of terminologies which comes later. Then we have to explain that theory again in between practicals. So if I drag more than if there are more theoretical lessons I have to teach you guys, then I won't be teaching you from 12th onwards. We'll look into those in the next month itself. Okay, we'll daily work on some data sets, so we'll be familiar with how to work on analysis part. And so implementation of t statistics and p values here. We'll move on to interpreting right, interpretation. Okay, these some of them I have given it in too detailed, which will make you lose interest in data science. It's not necessary for at this stage, but at some point it will come, and you will look into it by yourself. So don't worry about some of these things. Okay. So there I have given the hypothesis test in detail here. One tail test versus two tail test, what it is. Why are confidence intervals preferred? So, okay, I was before I get started the class, I was working on this, but I hit an error and I didn't have enough time to solve this. So there are two cells where I hit an error. So I can tell you, we'll continue with one-tailed and two-tailed error further now. So what basically one-tailed error is, one-tailed and two-tailed errors are. So there is something called two-tailed test. Sorry, not error, two-tailed test. So two-tailed test is where we check for any difference regardless of the direction. In the sense, we'll see in the extreme and both the extreme cases, the right side and the left side. Okay, that's two-tailed test, which means like for example, mean could be higher or lower, or most common. It's most common in real estate. So most of the time, mean is in when you come to the posh areas, the mean of the real estate would be higher when you come to the village areas. So that's what two-tailed test is. For if you look into the test scores, for example, whatever the test preparation affects the math score, right? So if you have done less preparation, then it will affect your math score. And one tail test is nothing but where we check for a specific direction or effect. For example, test preparation increases with math score. That we check. That's a one-sided, right? So here you won't check for both lesser preparation and and lesser math score, and higher preparation and higher math score. So that is two-tailed. Here in one-tailed you will see uh, test preparation as it increases with the math score. So when you don't have a strong reason for you to test one-sided, you should always do a two-tailed test, because it will give you the idea of what are the experiments you have in the data set. But if you do just one-tailed test for right side or the left direction, then you will have increasing. It depends on the data set. So increasing or decreasing, you won't be getting the sufficient hypothesis evidence. So always try to do two-tailed tests in hypothesis. There was a practical one-tailed, and so in the beginning I talked about confidence intervals, right? So what are confidence intervals? Consideration. Okay, here is confidence intervals. Okay, confidence interval is a range of value that is likely to contain the true population parameters with a certain level of confidence. Now, for example, there is a 95% confidence interval. We can say, uh, see in the see example, the population mean or proportion or difference between means. Okay, this is confidence intervals. Sorry. Yeah, it's been since it's been long for me about the data science. Like being a data engineer, I just prepared these notes by looking at the concepts what are important, but these are important, but not as of now. Okay, uh, so some of the things you'll understand while you doing this, but if I tell everything right now, it will be overwhelming. And I guess today's topics were a little bit complex, and it was most because it's mostly theoretical. I know you felt today's class as boring, but anyway, whatever we taught today, you understood and you noted down the concepts, right? So that whenever you feel like we are using it, you could go back and look into the you can browse the internet and get whatever you want. So okay, today I genuinely want I want to conclude here today, because it's whatever the topics I've prepared, looking at the notes, are quite complex, as well as it's not necessary in the first sixth day. I mean, today is the fourth day or fifth day. Fifth day, right? Yeah, fifth day. So here, what statistics can do, that you will see what statistics can do. Implementation of combine, that you'll see. Okay. So I want to wind up today's class because the topics are complex, and you whatever you learned till now, it's quite enough to start with the analysis process in the data. Okay. So tell me, shall we start with attendance, or do you have any doubts regarding today's class? We can start the doubt session after the attendance itself. Okay.